Yo, what's up, guys? Sorry, had to restart the stream really quick. Yeah, welcome back. Uh, Another video today. Some more problems. Yeah, we're gonna jump straight into it. Let's see here. Yeah, jump into some more problems today. So, minimum difference in sums after removal of elements has a 70% acceptance rate. Ooh. Take a look. Maybe we might just. I'm not really feeling it today. Maybe let's look at some problems here. Let's grab our website here, dude. Gotta find this. Here we go. Okay. Yeah, so let's jump into some 1500, 1600 level problems. Whoops, not reset. We want enter. Take a look. Go to page 12. We did this one yesterday. Minimum cost to make arrays identical. Let's take a look. Let's get our thing looking good. Get our Excali drawer. Yo, what's up, Ethan? Let's go, bro. Thanks for joining. Oh my gosh, dude. Remove subfolders from file system. Should we do it? This looks kind of AIDS. I think we will do it, but let's look at this one first, and we'll kind of see where we're at with time. Okay, so 3424 minimum cost to make arrays identical. You're given two arrays, array in AR and BR of length n, and an integer k. You can perform the following operations on array any number of times. Performing some operations. Let's go. Okay. Split array into any number of contiguous subarrays and rearrange these arrays in any order. This operation has a fixed cost of k. Choose any element in an array and add or subtract the positive integer x to it. The cost of the operation is x. Return the minimum total cost to make array equal to BRR. Okay, so we're given array here, and then we're given BRR this. We have k is equal to 2. What is k again? This and an integer k. Split AR into any contiguous subarrays and rearrange these subarrays in any order. This operation has a fixed cost of k. Okay. What was your background in coding before you started day 1? I just wasn't that good at Leetcodin. I had it was just when I graduated, pretty much. So yeah, I didn't really have any experience with Leetcode. I just graduated. I had a CS degree. That was really about it. Didn't really have any experience with like Leetcode at all. Yeah. So it was just kind of when I got started on my journey, like just learning. So why do you ask, KS8? I'm just curious. Choose any element and split array into any number of contiguous subarrays and rearrange these subarrays in any order. This operation has fixed cost of k. Does that mean every time we rearrange, it's at a cost of k? Educational background? Yeah, the educational background. I just graduated from my CS degree. That was all the education I had, pretty much. Okay, so let's grab this We have to fully understand this question. It takes me a while to actually fully understand what's going on. So let's grab our array here. Let's grab BRR. Here we go. Oh, let's put it down here. I think it looks better down here. Return the minimum total cost to make ARR equal to BRR. So I assume that they have to be the same. Okay, no, so we're taking the sum. Okay, so split AR into two contiguous subarrays, -7 and 9.5. Rearrange them. Because I assumed you knew next to nothing on day one, but you seem more advanced than I am, and I have some formal education in coding, but I suck. Dude, you don't suck, bro. You don't suck, bro. You're fine, dude. I didn't know nothing on day one. I had like an idea. I guess I had learned about, you know, like data structures, I guess, in a way. You know, through college. But I honestly don't feel like really you learn a lot in college. So, you know, I had to, you know, I guess I would say I was familiar with the data structures, but I didn't really know how to apply them. I feel like that's probably a better way to say it. And then I started Leetcodin and I learned like so much. So there are many different valuable skill sets in computing. Yes, I agree. Ethan is totally right. I just kind of learned, dude. Just start doing it, man. If you just start, that's all that matters. Just, you're going to fail, dude. You're going to feel like you suck, dude. I feel like I suck all the time, bro. Every time I turn on the camera and I'm doing these LeetCode problems, I feel like I suck. So it'll probably never go away, but I don't know. Just start, bro. That's really all the advice I could give you. Just start working on it. Just spend a little bit of day. I only do this for about an hour a day, an hour and a half at most. So just because you're not good at LeetCode doesn't mean you can't do data science with distributed systems. Yes, that is correct. Okay. Split array into two contiguous subarrays. Okay, and rearrange them. 9.5 -7 with a cost of 2. Subtract 2 from element array 0. The array becomes 7.5 -7. Split array. Choose any element in array and add or subtract a positive integer x to it. The cost of this operation is x. Return the minimum total cost to make array equal. I'm a little confused what's going on here. I'm not a fan of doing LeetCode problems at all. Yeah, they are kind of AIDS. They are kind of AIDS for sure. Just like this question, dude. I don't understand what I'm meant to do here. Us to make arrays identical. Can you explain the question better? No code. I need to get a better explanation for this because I'm really struggling at understanding what is going on here. With the why such twisty description. Maybe you just need to solve real world problems such as real website or making a game instead of just continued problems. I tried embedded game dev and usual comp science, tried C++, JavaScript, and nothing ever really clicked for me. Dude, KSA, bro, you just gotta keep going, bro. Like, trust me, dude. Like, I feel the same way, like, all the time. I think game dev was best for me since it has instant gratification. Yeah, dude, just don't give up, man. Just keep going. Like, every day you put into it, bro, like, you know, you're not going to see like instant results after 2 days, bro, but like, it's like going to the gym, dude. You know, like, you're trying to put on weight. Like, I'm trying to go to the gym. I've been going 8 weeks, right? I don't see much progress, but I've been going 8 weeks. But once I do it for 3 months, like, you know, I do it for, 5 months, I'm going to get way better. You know, you just got to, yeah, exactly, Ethan. It's just time and practice. Keep at it, and you'll get better. Yeah, just consistency, bro. Like, even if it's for like half an hour or an hour a day, just like keep going and just like never give up, bro. Like, just keep going. Elf, new here, you in college. I am in college. I'm a grad student, but I have graduated, so I technically am still in college, yeah. I got a semester left. Okay, so you're given two arrays times 1 times 2 of the same length. Your goal is to make these two arrays identical, meaning each I should be equal to nums 2i. So everything has to be equal here, right? So we need a... okay. Interesting, okay. However, you can't just directly change the elements. Instead, you're allowed to swap elements between nums1 and nums2, but only at the same index. For example, if nums I is equal to 5 and nums2 I is equal to 3, you can swap those two. It's also imperative that you accept failure as a key part of learning. Yes, sir, that is true. Especially with something as trial and error as software. That's some good advice, man. You can swap these two, and now nums I is equal to 3, nums2 I is equal to 5. Each swap has a cost, which is the minimum of the two values being swapped. So in the above example, swapping 5 and 3 will cost 5, 3. Okay. Make nums1 and nums2 exactly the same. So how can we make these two exactly the same? How do they do it here? Split array into contiguous subarrays, -7, 9, 5, and rearrange them 9, 5, -7. Subtract 2 from element 0, the array becomes 0. The cost of this operation is 2. Subtract 7 from element array 1. Array 1. 7, -2, -5, the cost of this operation. Cost is 7. Add 2 to element array 2. The array becomes 7 to -2, -5. The cost of the operation is 2. The total cost to make arrays equal 2 plus 2 plus 7 plus 2 is equal to 13. The intuition isn't coming to me here, dude. I'm not gonna lie. I'm not really sure how to solve this. I don't really understand what this K is for. And an integer K. Split array. This operation has fixed cost of K. Choose any element in array and add or subtract a positive integer X to it. The cost of the operation is X. Return the minimum. I'm so confused what K is doing. What's K doing in this question? Hi, I am from India, which is coding language easy to start. Python, bro. Just jump into Python, dude. I'm from India. Yeah, just Python, dude. Jump. Oh, you spamming it, dude? I can see it, bro. No need to spam it. But yeah, Python, dude. I would say what I'm doing. This is Python. Yo, stop spamming, man. Cluster make arrays identical. Why is K the minimum value important? When you have imbalanced elements, i.e. one value appears more in nums1 than in nums2, you need to fix the imbalance by swapping. K is a minimum value in the entire input. This is tough, bro. Like, this is really tough, this problem. I'm really not getting, like, any intuition here, dude. Oh, shit. I gotta look at these hints, dude. What does Operation 1 rearranging subarrays actually accomplish? Also, I'm actually rich. I was curious if you have looked at code, test case, test, result, test. If you ever looked at code, test case. Oh, 420. Copy paste issue 420 strong password checker. I have not. I have not looked at that problem. Maybe. Let's see if I've solved it. I don't know. I don't think so. No, I have not. I have not solved this problem. Holy shit, that's a low acceptance rate, dude. Oh my gosh. Have you done this one, Ethan? Maybe I'll look at this one next, dude. Okay, what does this actually accomplish? What does rearranging it actually accomplish? I don't know, dude, to be honest. Yeah, this one I did it as a 2-part problem. When did you do it? Was it a while ago or did you do it recently? Kane 7. K is the minimum value to swap. Dude, I am lost on this problem, dude. I don't know what to do. Calculates. Has a 36% acceptance rate, this one. I think it's actually a good problem. I tried it yesterday. It took me around an hour or so. From where? Okay, I'll try it out after this problem. From where to learn Python. I don't know, dude. YouTube, dude. Jump on YouTube. There's a bunch of good resources on YouTube. Or just start Python documentation. Just yeah, YouTube, dude, or just start making stuff and look at the documentation. Anything like that. Yeah, dude, I am not sure, bro. Bro, I am so lost with this, dude. I have no idea how to solve this, dude. Like, arrange the number of continuous subarrays and rearrange these subarrays in any order. This operation has a fixed cost of k. Choose any element in an array and add or subtract a positive integer x to it. I guess we have to... I have to ask for some hints, dude. Give me some hints. I don't know how to solve it. Think about how many times each number appears across both arrays. If any number appears an odd number of times, you cannot make the arrays identical. Try combining nums1 and nums2 into a frequency map to check this. For every index I, if nums I does not equal nums 2i, it's a conflict. You want to collect these mismatched pairs and figure out how to cancel them out. Track which elements are in balance. Count how many extra times each element appears in nums 1 versus nums 2. Okay, so first step is understand when it's impossible. Think about how many times each number appears across both arrays. This is a tough problem, bro. For me, dude. This is tough as fuck. I'm not even sure where to begin. Usually I can have a good idea about where to begin. Does anyone have any idea? Ethan, do you know how to like think about this problem, dude? I'm kind of lost, bro. I don't know. I need small, not even advice, just a chat. I'm a bit confused. Currently my second year at comp sci, completed a college out of 4. I'm interested in web dev, but seeing the condition. Your message got cut off, bro. I didn't really see all of it. Minimum cost to make arrays identical. Dude, honestly, I'm gonna look at a solution, dude, because I generally have no idea how to solve this. Like, I'm just gonna read about it because I'm curious. Score A list, B list, return minimum. Sorted AR, BR plus K. For A, B, and zip. Is that all he's doing, dude? He's just counting the difference between A and B? There's no way that was it for the problem. Dude, I thought there was so much more to it with this, like... I think this is what's throwing me off, the swapping and everything. Splitting the array into contiguous subarrays and rearrange. Didn't someone say that in the description? Tealy gang. So both array and take absolute difference between each corresponding element plus K. In the condition of web dev, I feel like I should switch, but the thing is, I'm trying to make new tech projects, vector database, AI integration is all you can think would be good, or should switch to something else. Dude, just do what you enjoy, Elf, dude. Just, if you enjoy it, bro, just make projects and stuff, dude. Like, there's no, don't worry about the job market. Yeah, the job market might be AIDS, but just, like, just do what you enjoy, bro. And just keep working at it. Just keep going. Don't worry about everything else. So what he does here, he makes a helper function here. What was throwing me off here was the swapping, bro. Like, the way it was confusing me so hard when, you know, we're splitting up this array here. You know, we're having 7, -2, -5. You know, I just don't feel like I'm understanding the question fully. Maybe that's why. Split array into any number of continuous subarrays and rearrange the subarrays in any order. This operation is a fixed cost of K. So to rearrange them, it's a fixed cost of K. I think that's what I'm getting from here. This guy here just makes a helper function. What passes in, let's do array 1, array 2. So he takes a res here. He zips each element in the array. Array 1, array 2. Is plus or equal to the absolute value of A minus B. So it takes the difference between both of them and just returns res. There's no way that is all there was to this. Like, min score takes AR, BR, and then takes the sorted version of both of them and compares the minimum value. Sorted array, sorted BRR plus K. Alright, there's no way that's the end of the problem, dude. That's insane. Bro. That's crazy, dude. I cannot believe that is the answer to the problem. Like, how, like, here's your K. You can perform the following operation on array any number of times. Split array. Rearrange these subarrays. At ELF, as a second-year student, I would probably try to deepen your understanding of programming principles before trying to craft novel techniques. There you go, dude. Let's go, Ethan. How to subtract the positive integer x to it. Cost of this operation is x. Yeah, guys, I am lost right now, dude. I don't understand how you can think of it to do this. Like, I don't get, like, I'm gonna submit this. Does this submit? Wow, that is insane. Minimum cost to make arrays identical, yeah. You know what? Screw this problem, dude. Dude, I'm already lost with that problem, so screw that problem. You will naturally come up with novel techniques to problems you're familiar with. Let's take a look at that password problem. Here, I'll take a look at this. Password is considered strong if the below conditions are all met. has at least 6 characters. Let's see if we can solve this. Password is strong if the below conditions are all met. It has at least 6 characters and at most 20 characters. It contains at least 1 lowercase letter, at least 1 uppercase letter, and at least 1 digit. It does not contain 3 repeating characters in a row, i.e. BAAA is weak, but AAAA is strong. Given a string password, return the minimum number of steps required to make a password strong. If password is already strong, return 0. In one step, you can insert 1 character to password, delete 1 character from password, or replace 1 character of password with another character. Okay. I feel like this is a good problem, Ethan, not gonna lie. Like, okay, so how many? We need at least 6 characters here, right? So that's why we have A. We need to add 5. That's why we get that here. We have AA1 of length 3. The reason why we have that is because we need at least 6, right? And at least 6, at most 20. It contains at least 1 lowercase letter, at least 1 uppercase letter, and 1 digit. It does not contain 3 repeating characters in a row, i.e. BAABB. 0 is weak, but BAAAA is strong. 3 repeating characters in a row. Okay. Okay, so let's write this down. So we need at least 6 characters, at most 20. We need this one. We need this one. Okay, so 6 characters, at most 20 characters, 1 lowercase letter, 1 uppercase letter, and at least 1 digit. Okay. So how do we want to think about this problem? How can we keep track of all this? Well, we need we need to think about this, right? So if we're given, I'm thinking probably thinking about some sort of hash map maybe, right? Okay. I'm thinking there's got to be so many edge cases in this, bro. Like, it's insane. Like, you wanna, if it's easy to think about it, if you were to sort the arrays. Are you talking about this question, Ethan? I don't know if you were talking about this one. I'm not sure. I don't know when you sent that message. Sorry, I didn't see it. Return the minimum number of steps required. So returning an integer. Okay, res is equal to this. I feel like we have to... What do we want to think about? Well, we need to think about inserting a valid integer. I guess there's so much to think about here, so there's probably so many different edge cases. Okay, so let's take the length of our password. We'll have our res is what we're going to return. That was for the previous problem. Okay. I guess we probably want to think about this in maybe different parts, right? I feel like the first part that we want to check I guess we have to make it valid every time. If the password is already strong, we return 0, right? So I guess we want to think about it in different parts, right? We can think about, on Discord, I sent you on my main function with implementation details hidden so you can see my thoughts if you wanted. Okay, let me see. So you have a bunch of different helper functions here. Thank you for that, Ethan. Appreciate it, dude. So I was thinking about it right. We need to think about it in different parts, right? There's multiple different parts of this problem. Find repeating sequences. Okay. Okay, so let me fix this up. Hang on. Okay, so let's think about it like this. First of all, let's think about our function. 1. Let's think about finding this, right? We need at least 1 lowercase letter, 1 uppercase letter, and 1 digit, right? So maybe we can have some sort of helper function here that what do we want to call this? Count missing types, right? We want to pass in our string, right? It contains at least 1 lowercase letter, at least 1 uppercase letter, and at least 1 digit. I don't feel like really we have to like actually build the string, right? We only need a count, right? And that's a thing, right? So we want to just mainly count, right? We want to count each. So if we're missing 1 lowercase letter, or we're missing 1 uppercase letter, or we're missing 1 digit, at most we can return an integer of 3, right? Or 2 or 1, right? So I feel like that's probably the way to go about it. So really, how do we want to do that? Well, we'd probably just want to loop through our password, right? So we can have a we can have missing types, right? As an integer, right? We can loop through for num in password, right? I'm thinking about how can we count this? Well, we can probably have flags, right? Like we need at least 1 lowercase letter, right? So maybe how can we tell if it's lowercase letter? Well, shit, bro, there's probably so much to this problem. I feel like we can have has digit is equal to false, has lowercase is equal to false, has uppercase is equal to false. Is there a better way to do this? Returns false. If the iterable is empty, any also returns false. If num dot is digit, we can return true. If num dot is lowercase, is that what it is? Is lowercase? Is that? Is lower. Method builds a string used to determine if all case characters of the string are lowercase. Okay, is lower, right? So we can check is lower here. Is lower. What is digit? Is digit. It's all lowercase too, I think. Is digit. Not return. We want to make has digit is equal to true. Is lower. Has lowercase is equal to true. My code's probably going to be so bad, but that's okay. If num dot is upper has uppercase is equal to true. Okay, so we have that. Then this probably can be designed, this function, so much better. I feel like I'm kind of doing it like a noob, but it's whatever. I mean, we can check separate if statements every single time and just add one. Types is equal to 3 minus can you do it like that? Is it like 3 minus has digit plus has lowercase plus has uppercase? 3 minus all of this, right? Then we return missing types. Does that work, dude? I have literally no idea if that works. Let's call it. Let's do res plus or equal to has count missing types. And then we want to pass in a password. Let's print out res. std 2. Okay, so that worked, I think. Right, because really we should only return 3 minus 1, 2. Yeah, okay, so that worked. Okay. Good. So now we've got 2 here, right? We're expecting 5, right? So we've done our first part of the problem, which is probably the easiest part, to be honest. We need... It does not contain 3 repeating characters in a row. So how did you do it, Ethan? You did int missing types is equal to std vector int sequences is equal to find repeating sequences. Why inside of a vector though? Are you taking... Why do you store it inside the vector, Ethan? Why do you store your find repeating sequences inside the vector? Are you storing indexes or something, or... Indices. Okay. Let's move this down here, bro. So I guess we can have another function here, def repeating sequences. What do we want to pass in? Just passing out password, right? How do we want to design this function? Well, what do we really want this function to do, right? So we have this array, right? We're passing in a return type of the indexes, right? So if we have repeating characters, in this case it doesn't have any, but maybe we can add some, right? Let's say we had this, right? We had the 3 repeating ones here, right? Whoops. We got this one, this one, this one. That was so bad, dude. Oh my gosh. Right. Really, we're going to be stuck at this index here. And we're going to check, well, there's I plus 1, right? I plus 2. And if they are, we're going to store some indices in there, right? Again, here, Ethan returns a vector. If n is less than min password length, handle too short, max password length, return handle valid length. Okay, so he split it up into 3 different things. But why the indices are you returning here? Probably don't want to check +1. Actually, now I think about it, probably would want to be -1, right? So really, if we want to check that, we'd start at I is equal to 2, right? The reason why we don't want to check plus is then we have to deal with going out of bounds. We have I is equal to 2. Right. Probably need like some sort of count variable or something. If we loop through for I, so we already got an I, let's do for I in, I guess we don't really need to, we could just start it like this. For I in range, start at 2, go to the length of password, right? Then we check, okay, well, if our nums, is that what it's called? Nums? No, password. If our password I is equal to password I minus 1, and password I is equal to password I minus 2. No, that won't work, right? Because it could be longer than 3, right? We might not always have triple 3s, right? there could be like 6 threes, right? So maybe when there could be more than that, I mean, a for loop could work. I mean, I think it will work, but we'd probably need a for and some sort of while loop to keep going, right? But how? How do we want to design that? Well, I is equal to 2. While I is less than the length of password. And we go, okay, well, if password I is equal to password I plus 1 and sorry, not I plus 1, minus 1. Whoops, minus 1. So what I'm thinking here is I'm thinking of for, right? We check with an if, and then we have a while here that keeps going just in case we have more 3s, right? That's what I'm kind of thinking here. Password I is equal to password I minus 2, right? Then we would start with our while, right? And we would go, okay, well, while hello, bro. Age Buck, dude. What's up, bro? Hello. I feel like now that I think about it, dude, Ethan, I feel like I'm doing this wrong. You were returning an array of indices, but technically I'm counting. Could that still work, though? Could I just count how many repeated characters we have? But I should probably... I assume now that you keep those indices because... Well, no. I feel like we don't have to edit the... Because you're passing sequences into handle vowel length, handle too long, handle too short. So obviously we're not making any edits to our actual string. We're just like really counting the math, right? Is less than the length of password. And we can do word, oh sorry, password. Password I is equal to password I plus 1. Shit, I didn't do a thing here. Our length is equal to 2 here. We would do length plus or equal to 1. Right, that works. While I is less than the length of password and password I is equal to password I plus 1. No, actually, maybe the other way, sorry. Why were we looking forward? That would go out of bounds. Now that we've got a while though, we have to. What if it doesn't? We probably just want to move. So I'm trying to think here, dude. Plus equal to 1. Right. You here, Ethan, dude? I'm a little stuck. Am I thinking about this wrong, bro? Well, I is less than length password, I is equal to... Yep. We start our length here, and then we do our while here. We increase our length after each value. We push I. But do we want to count our indices here? And we could count our indices, right? So I believe that's what Ethan's doing here, right? He's handling if it's too short. We have our missing types and our N. Right, so I assume what he's done here is that he's got his handle too short. So we'd add the missing types, right? We handle a valid length, which would be just fucking with the sequences and the missing types, right? And then we have the handle long. It's probably the most difficult one, to be honest. We can have an array repeating seq is equal to this. We could store each value of repeating sequences, right? We could. And what's the point of having a length here, right? I mean, yeah. Maybe let's go about doing that because I kind of want to follow what Ethan's done so far. I feel like the way he's thinking about it or the way he's breaking it up is pretty solid. So maybe we'll have our sequences array here. Back, had to take a call. Okay. We have our length here. So instead of this function here, bro, I was starting with the length, but now I'm thinking I probably shouldn't even take the length at all because really, I like what you said, I should be taking the indices. So really we can do sequences.append and we can append our password I-1 sequences.append our password I-2, then loop, get rid of our length, take our sequences append password. We just want I, right? Each time. Right? And then outside of this while, we would just want to return our sequences. Right? Which I believe we just want to call down here. So we would just do I guess we can call it sequences here is equal to repeating sequences. We want to pass in our password, right? Let's print out sequences. Let's see if we get any errors. Shit, well, we're not given any test cases. Define the repeating sequences. I use a sliding window or 2-pointer approach. Not sure how to classify it. Okay, I feel like this is probably a sliding window approach, kind of in a way. I just think we're not getting anything here because maybe we can create our own test case. What if we did like shit for, and we do like A B O. Let's just do this. I don't know. I feel like that's a fine test case. I don't know. I think that's valid. One, 2, 3, 4, 5, 6, 7, 8, 9. Why? How many did I put in here? 3, 4, 5, 6, 7, 8, 9. So that worked. Right? They gave us 9. So this is working, but we're storing the actual value. We want to store the index, right? So we'd want to store I. I minus 1. And we'd want to store I minus 2. One, 0, 2, 8, 7, 9, 10, 11, 12. Holy shit, dude. What the fuck is going on here? Okay. Yeah. I guess that works. Maybe sorting this might be... I sent my own CPP code if/when you want to take a look. It may help with your thought process. I think this works though, Ethan. Maybe we return the sorted version of it. Maybe so it looks a little bit better. Yeah, like this works. What I've done here. This is a sliding window approach too. I'm looking at your thing right now. SCD vector in sequences, yeah, and I, while I is less than n and j is equal to I. While j is less than n and password j is equal to password I, j++, if j minus I is greater than 3, sequences dot push back j minus 1. So I think we have a similar kind of approach here. I feel like we're kind of doing a similar thing. J is less than n. If j minus I is greater than or equal to 3, sequences dot push back j minus I. Why are you checking the if here if it's greater than or equal to 3? Am I missing something or? It does not contain 3 repeating characters in a row. Oh. So what if there's more than 3 repeating characters in a row? Do we have to, is that why you have that there? We can only have 3. Is that all at once? I'm just adding everything. Well, technically, I mean, I'm adding everything that's above 3, right? Because if we had 2, it's not going to work. If we change this test case and this had 2, it won't. We get rid of this. Yeah. So you wanted groups of 3. Sequences don't push back j minus I, but you're still pushing the index. So is this technically correct, what I'm doing here? Right, I'm taking all groups. There's 6 A's here. I'm taking all the A's, but should I be doing them in groups of 3? if it really matters, to be honest. I think we're going to go with what we got. Maybe we can come back and change it later. Right, so now we want to think of the 3 different ways we want to go about this, right? We have 3. I was finding the start of the group. Oh, okay. Okay. So what if there was a group of 4? You didn't really add it if it was a group of 4? Or like you wouldn't... If it's greater than or equal to 3... Sequences dot pushback J minus I. Oh, okay, I see. I'm reading it now. Okay, so you're going until you get that. It doesn't matter, really. Yeah. Okay. So while J is less than N, J is I, increase J. We're really going to increase J, and then we're going to do J minus I is greater than 3, then we do this. Okay. Okay, that makes sense. Okay. I was getting a little confused with the fucking squigglies, dude. Throwing me off. Okay, so we want to think about this in 3 different ways, right? One being we want to deal with the case where it's too short, right? 2 would be a valid length. And then 3 would be if it's too long. Hang on, I gotta deal with my roommate's cat. Hang on 1 second. I'll be back in a second. Okay. I'm back. Doesn't really matter. You can insert characters. Okay. Anyway. Okay, so we got too short, valid length, too long, right? I guess first we want to handle the case. We have N, right? So I guess we want to do, okay, well, if N is less than our max length is 6, right? If N is less than 6, what do we want to do? Well, we can call our helper function here, handle short, and we can pass in N, and if it's too short, we want to look at the values that we're missing. So we come back up to this function, count missing types. Really, we have 2 missing types here. What do you pass in here, Ethan? You put in missing types. You pass in missing types here. What are we returning again? We given a string password, return the minimum number of steps required to make the password strong. Okay, so missing types, right? So really, what would be our handle short here, right? So we would create a new function here, def handle short, passing in our n and our missing types, right? We can say, okay, well, what do we want to check here? We want to see, I guess, how short we are. What if we had, yeah, but what if we had a bunch of repeating sequences though? We'd have to also handle that too. I feel like this either could be super small, or this could be like a couple lines, or this could be like a huge function. But I'm trying to think about what to do here. Like, what if, again, I feel like I'm overthinking it, but what if we had like, you know, repeating functions? Like we could have like a. Like, how would we handle that there? Well, then we would have two missing types, right? If we had a, because we'd only have one lowercase, right? So how would we handle that though? I'm trying to think here. What would be the best way to handle? I'm kind of lost. Well, let's think about it, right? If we had, let's think about the most base case first, right? If this wasn't a thing, right? I feel like I'm overthinking it. If we didn't have to think about the repeating characters, we would think about just returning whatever that may be. How would we figure out how many missing types we have? If we're less than the thing, how many missing types would we have? But we would do let's think of a comment here. What would we do? We would do, okay, well, we would have, I guess we would do, what, 6 minus n? Right? 6 minus, right, because we need at least 6. Right, and how many characters are we away from reaching 6? No, that wouldn't work, dude. I'm overthinking this way too hard, I think. There can be a max of 3 missing types. So I guess maybe either it can be return it can either be 6 minus n, right? Or it can be missing types, right? That we need. Because, right, if we were to think about a normal function, right? If we had a normal one that had all the types, right? We had a big one, a little one, we had a number 6, we had like n, like c, right? This is completely valid. All we need is one more n, right? In order to get 6, right? To get 6, we just need to add in any random letter, number, or whatever that can be, right? So we would have 6 here then, right? So really one of them would be 6 minus n, which is the current length, right? And then the other side would be, well, if we had something invalid, right? So let's say we had like, oh, bro, you gave it to me, bro. Called you in the stream for this problem, so I'm not just spamming your chat. Let me know. I think you're doing really well so far. Thank you, bro. It's okay. Okay, thank you. Yeah, that's what I was thinking, right? So we have 6 minus n, but then we have, I was thinking we would return our missing types, right? Right? 6 minus n or missing types, right? Because if we had our missing types, in order for it to be valid, but what if we had a here? How would missing types make this valid? Because we'd just be missing 2, so really we'd be returning... Oh, we would return 8. Oh my god, dude. I am so stupid, bro. Holy shit. How did I not think about that, right? Wait. Holy shit, dude. Am I confusing myself? Right, because we currently have our res. Wait, bro, am I tripping hard, dude? Oh my gosh, dude. I thought I just had a light bulb moment, but maybe I didn't. Like, A, right? We would have 2 missing types here, right? We would return 2, right? And when we return 2, where's our code here? Return handle short and missing types. We wouldn't return 2 here. I think I'm getting confused here because I'm doing an instant return here. Would we instantly return here? But then we're going to instantly return 2, right? Isn't that what you have there? You have minuscule, wait, hang on. SCD, max, missing types, min, password length, minus length. Okay, that's what I have, right? But why wouldn't we just return 2 here, Ethan? If you're returning in your thing, you have return handle short, right? And you're returning 2. How would that be the right answer? What are we returning here? The minimum? Wait, maybe I'm getting confused with what we're returning. Given a string, it says return the minimum number of steps required to make password strong if password is already strong. If password is strong, return 0. Why would we return 2 here? Wouldn't that be incorrect? Because if we had 5 A's, right? Oh, fuck. Okay. AA dollar AA1 AA. It is 2. I'm saying you're exactly right. The code I paste is equivalent to yours. Yeah, I know, but I was... Okay. Oh my god, dude. I'm overthinking it. Fuck. I'm overthinking it way too hard, bro. Oh my god. Okay. Okay, well that works. Okay, so this is our 2 short, right? Now we have to handle the case where it's a valid length, right? And what would it be a valid length? Well, if... What do you check here, Ethan? You check if n is less than or equal to password length. Okay, if n is less than or equal to password length. sorry, you've got max possible length here. I need to do 20, right? If n is less than or equal to 20, we will return handle valid length, and we pass in sequences and missing types, right? I like how you kind of broke down this problem into like different functions, right? Like it was a good way to like help me think about the problem, the way that you broke it down in terms of the functions. But anyway, okay, so now we have to do our function here, def handle valid length, and we pass in, what are we passing in? Sequences and missing types. Okay, got a typo here, missing types. We got sequences and missing types, right? Holy shit, dude, I feel like I've been going on this problem for like forever now, bro. Like, okay, so now we want to handle our valid length, right? How would we handle our valid length? We've got our sequences and we've got our missing types, right? So really, what would we want to do, right? Probably we'd want to handle our missing types first, right? So I assume we would just add our missing types, right? And then what? Probably, I'm thinking, would we have to handle our length here? Shit, dude. Damn, bro. I wish it was easy as this one. How would we handle this function? So I'm thinking step one, right? I guess we have to break this up into smaller parts, right? Step one, we want to handle our missing types. I feel like, right? We've got to add our missing types, right? So I'm thinking here we're going to have some sort of like count, right? Being 0. Right? And we've got to handle our missing types first, right? And then I feel like we've got to check, right? After handling our missing types, could we be greater than our 20, right? Because if we are, then maybe we have to, well, I feel like we're going to probably remove, we handle our missing types, 2, then we handle our, holy shit, dude, we're gonna be checking so many different things, dude. Now I think about it, right? We're gonna be handling our missing types. We're also gonna have to handle our repeated numbers, right? But as we handle our repeating numbers, we're gonna have to keep track of our bounds, right? Because we're gonna have to check, well, if we're going greater than 20, right? This probably wouldn't happen here when we're dealing with these repeated bounds, but if it's a valid length, you only need replacements, not insertions or deletions. To break repeating sequences, every 3 consecutive charges needs 1 replacement. You only need replacements, not insertions or deletions. To break repeating sequences, every 3 consecutive charges needs 1 replacement. Great work. Thank you, Hazani, dude. I'm getting AIDS, dude. How can we do this, dude? So we're counting each value here. So we loop over this every 3. We would add 1 insertion, right? So for I in sequences, actually for I in range length sequences, right? If our oh my gosh, dude. If our since I'm storing each number, I feel like I'm going to have to check, well, this one, and this one, if we've seen 3 in a row. For this, instead of taking the max of the missing types and min length minus current length, you can take the max of missing types and the amount of needed replacements. Ah, man, dude, I'm confusing myself now, dude. Literally. Instead of taking the max of missing types and min length minus current length, you can take the max of missing types. Honestly, Ethan, I'm a little bit confused what you said. I feel like I'm confusing myself for this function. Like, it length and missing types. Bro, how long you code every day? I don't know. I just code for fun, bro. Sometimes it can be like 10 hours, sometimes it can be 0. So, I don't know. I just like to do it, so it's fun. Check Discord for some non-implementation specific code. Oh, bro, I'm so lost, bro. Oh my. Dude, this is so AIDS. I don't want to give up though, dude. I'm so close, dude. Fuck. Ugh. Shit, dude. What is this problem? Check. What is this problem rated? Dude, I don't know. I have no idea, dude. Should we check? See if it has a rating. Strong, password, checker. Is that what it's called? Yeah, this one hasn't been asked in a contest, so I don't think it has a rating. But like, I mean, if it has a 14% acceptance rate, heap priority queue. Oh shit. Okay. I'd say it's a pretty tough question for sure. Like, instead of providing my crap code, this is a really tough question, dude. Like, for sure. Took me a week of painstaking coding 1,000 LOC, unless I don't know what this means, but as a take-home challenge, I don't see how you can complete anything. Just a superficial discussion of your approach to the solution in a 1 hour of an interview. I learned quite a bit, a lot of retrospect after I finished the challenge. The test cases are plenty and trustworthy. I think if you manage to get the too short case and valid length case, that's a big win. The handle too long case is the most involved by far. Yeah. Yeah, dude. I don't know. I'm trying to think here. I think I can do it, dude. I gotta lock in though, dude. Like, LOC lines of code. Oh shit, I didn't know that's what that meant. What did he say? He had 1,000 lines of code? No fucking way, bro. What? Wait, hang on. Where was that at, dude? Oh my god, dude. This guy's description, dude, isn't insane, bro. What the fuck is this? Like, took me a week of painstaking coding and 1,000 lines of code, unless it's a take-home challenge. Bro, I want to complete this. I want to complete this, bro. Like, I feel like a fucking dog if I complete this, bro. Low key, like. But if long, bro, is even harder than valid length, bro, there's like probably no. I'm gonna need your help, Ethan, for sure. Like, dude. He implemented this standard library. He implemented his own standard library to solve this. Oh, okay. Yeah, bro. You. Dude, fuck me, bro. Handle valid length. Okay. If you want to call, let me know. Let me give me another 5 minutes, dude, of solving this problem. Of solving this. I want to see if I can get this. And then I'll probably need help with the last bit if I can get this. I don't know. I'm trying to think here though, like, so if I have my repeats here, right? Would I just, instead of repeating, can't I just take the length of them, right? Because really, however many I have, I just divide it by 3, right? So if I take the length of our sequences, right? So I take the length is equal to the length of sequences, right? My count is 0. I'll get a length of 6. Or if it's a length of 5 or a length of 4, if you divide it by 3, it'll give you the amount to add, right? Or the amount of insertions that you want. So, dude, there's no way it's fucking this simple though, but like, if I did like length divide by 3, if I did the length is equal to the length of sequences divide by 3, and then we return our max being our length or our missing types. Yeah, you're on the right. Okay. There's no way, bro. It's nowhere near that simple, bro, for sure. Like, but take the length of these sequences, right? Because we get 2 here, and we will return the max of this or the missing types, right? Because either you could add either, right? And that's why I think I was getting confused over here, right? Is this right, dude? Or is this... I have no idea. Like... Is this correct, Ethan? Or no? I mean, I don't think it is, but like, am I closer, dude? In a way, I guess. Dude, this is definitely the most cancerous problem I've ever done for sure, dude. Like, Trying to think, dude. Holy shit. Oh, bro. Not quite, but you're trying. But you're thinking about it correctly. For each sequence, if the length of the sequence is greater than or equal to 3, you need the length of the sequence divided by 3 replacements. Well, like... You're saying for the length of each sequence, but aren't I technically doing that? Like, if this was 2 separate sequences, right? Like, if this test case had an extra A here, right? And we would have run this. Oh, shit. Whoops. Missing types. It's not defined. A divided by 3 is equal to A divided by 3 is equal. Why am I getting an error here? This needs to be missing types. Whoops. That's why I'm not getting it. Oh shit, dude. I'm actually passing some test cases, bro. No way, bro. Here, bro. Let's jump on a call, dude. I think I need to talk about it with someone. Hello?
Yo.
Oh shit, dude, my headset isn't on. Hang on. Okay, can you hear me?
Yeah, I can hear you.
Okay. So how do I think about this, bro?
Okay. Here, actually, can you share your screen first, just so I'm in real time? Okay. So we're just thinking about the valid length case, right?
Yeah, this one. Yeah.
Okay. And I realized I did take a different approach. Like, so my find repeating sequences isn't taking the indexes. That was my first approach. But I think it's better to actually take the length, and that's what the J minus I is doing. It's taking the length of the sequence.
Oh, so instead of storing all the indices, you're just storing the length.
Right. Because whenever so really, like what I was trying to type in your chat, right, is think about like A next to each other, right? How many characters do you need to replace to break up that sequence of 3?
1.
And then what about if there were 4 A's next to each other?
Would be 1 again, right?
Right. And then same thing for 5.
Yeah.
And then once it hits 6, you'd need 2. So for all you need to do is you need to iterate through the sequences that you detect. And that's why I ended up taking the length, because the length is all that really matters.
But if I'm taking the length of the sequences that I have here, technically I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9. What is this? Yeah, 9 here. Wouldn't that still work even if it was 8 or it was 10 or whatever it is? Like, I still divide it by 3 and that would be the amount that I would need? No?
Wait, what do you mean exactly? So you have the indices here.
I have the indices stored in an array, and I'm just taking the length of that array, dividing it by 3.
Okay, so you have all of the indices of the sequences, and then you're dividing the entire thing by 3. So, okay, so for this case, for example, the length is what, 4, 5, 6, 7, 8, 9?
The length is
It's
9.
9? Okay. So if you're taking 9 divided by 3, would you need 3 insertions here? So you could do 1, 2, 3. Yeah, that's, I mean, that works for that case. Yeah, that seems like it would work too.
So what I have
So
is
yeah,
correct?
I think so.
Oh,
Yeah, it seems like it's doing the same thing. Yeah, just my approach was slightly different, but it seems like since instead of taking the lengths, you're taking the indices, this also would work because the length of the container is the amount of indices.
okay.
This is what I was here. I'll just send you this because this was my. So you know how I had the calculate replacements needed function.
Um, hang on. 1 second. My girlfriend just called me, bro. Hang on. Let me. Sorry. Yeah, sorry. You can continue, bro. My bad. Sorry, I had to answer the.
No
Wait.
worries. So you see in the code snippets that I've pasted in Discord here for my handle valid length.
Yeah.
So I have calculate replacements needed, and then I'm passing in the sequences, and this just contains the length of the repeating sequences that are 3 or greater.
Right. Okay.
So all my function was doing is very similar to what you were doing. So since I'm storing the lengths themselves instead of the quantity, I was just iterating through each of the lengths and determining if it was greater than or equal to 3, and then if it was, then I would increment my total replacement count by what you were doing earlier, which is just taking the length and dividing it by 3.
Okay. Okay.
But yeah, you're doing it on a bigger scale, which I believe would be the same in all cases. I guess you just have to run tests in order to see if it passes everything, but it seems like it would work.
Okay. But you said the hottest one is the too long, right?
I don't even want to say. Okay, so it is difficult. Yes, I would say it's definitely the most challenging. I mean, you have all the intuition that you. The only thing that you're going to be doing here that's different from the other checks is so if it's too long, you don't need to insert anything at all, right? But you will need to delete and then replace.
Yeah.
So what I did first is I determined like how much I needed to deleted out of the password, and then I would calculate the replacements needed if there were any repeating sequences. Because again, the way I was thinking about it is you only need replacements if there are repeating sequences. Realistically, like that's kind of how it works out. Because otherwise,
So
like
if you're greater than 20, right, you only really need to remove your repeating sequences. Is that what you're saying?
Right. Well, we would still take, so no matter what, you're going to add in the deletions needed, but it would still be the maximum of the missing types or the replacements needed, like whichever one's greater. Because you can think about it as, okay, if I'm missing like a case, right, is imagine, because if you scroll down, one of the constraints is it says password consists of letters, digits, periods, and exclamation points. So imagine a password that was 22 periods long, right? You would have 3 missing types. So you would need but the replacements would still be greater than that, right? But imagine if you had a unique password that was still too long, you would calculate the deletions. So let's say it was like 2 passed. So you take 2 plus the maximum, like we did before, of the missing types and the replacements. The only thing you're doing different is adding in the deletions. So the challenging part is calculating the deletions.
Right. Okay. Okay. I think I'm going to finish the rest of this tomorrow just because I want to work on C++ and do some other stuff. I got to be up early again, so.
Okay.
I'm going to finish this problem tomorrow, but I feel like I made good progress on it, though. Do you think? Like, I was thinking about it pretty well. I feel like throughout it was good, like, having your main function because it helped me think about the problem better. Like instead of thinking about it all in one picture and like a big picture, which is definitely like not how you want to think about it, like breaking it up into small parts was like just helped me so much. So
Yeah, I think that you were going about it in a very like intuitive way for sure. Like you definitely did, like really like your only problem is you're overthinking, right? It's like you're like you definitely have it, and then you'll like
yeah.
second guess your intuition. But I think your intuition is spot on most of the time.
Okay. All right. Okay. Well, I'm gonna end
yeah.
the stream. So okay, I will finish the problem tomorrow. I'll be back. Appreciate you guys. I will see you guys later. Bye bye.